Here is our halfway project report for our data mining project. First, we read in our KNN files. We read it in as a hash set for the total amount of words and a nested hash map for the term vectors, with each string being the email name, and the inner hash map calculates the string as the word, and the double is the amount of times the word appears in each email. It just cycles through for each file and inputs them correctly into each hash map, and calculate or counts the amount of words. It puts the word in. If the word does not appear in the hash map already, it will put it in as 1, the initial word in. Then it goes to KNN, where we bring in the test vector with the same way, with a hash map, saving it to a hash map, and we calculate the nearest neighbors. So our find nearest neighbor method calculates the dot product divided by the distance. Our dot product goes through and does the dot product of the words in our test data times the words, how many times the word appears in our test vector, and multiplies them together, and we'll add them all up. Then our distance is calculated by the total amount of times it appears in our test vector squared, add it all up, and the total amount of times it appears in our training vector squared, add it all up, and you multiply those together while taking the square root of both of them, and it returns the distance. Once we get that, we're able to do our result for our cosine similarity. So we do the dot product divided by the distance, and then we put that in a cosine similarity hash map. This saves the results of the cosine similarity to the name of the email that was just read through. After that, we calculate the nearest neighbor by cycling through the cosine similarity and finding the greatest number. Once the greatest number is found, we put if the email first 2 letters are equal to SP, then we put it in and count it as spam. If they're not, we count it as not spam, and we delete that, and then we cycle through as many times as KNN, whatever number's inputted, and it would find the greatest every time through, and then remove that number. Then we are able to see if the amount of spam is greater than the amount of not spam, or vice versa, and classify that as spam or not spam. For naive Bayes, we basically read in the same way with 2 hash maps, calculating if how many times a certain word appears in the email, instead of calculating the total amount of times it appears in one email. It goes through and it calculates if it appears in an email, it adds 1, and every time it appears in a different email, it'll keep adding 1 to that. Then we go in, and I get the probability of each word from we read in our test file. You get the probability of that word being in spam. If it's returned as 0, you do the Laplace smoothing, and you take the log of that and add it to the spam probability, and you do the same with the non-spam probability. Then you find whatever is greater, and you're able to classify that as spam or not spam. Then you're able to calculate by doing the accuracy to see if the accuracy is what is required. So if we run the program, as you can see, the naive Bayes accuracy is 99%, and the KNN accuracy with a KNN of 19 is 87%.